It's working. I will begin with a word of prayer. You guys have a good weekend? Pretty good.
What wasn't?
There was something. Nothing of consequence. I can't remember it. It wasn't the most awesome weekend ever. It was a good weekend, but, you know. Oh, I did start the weekend by watching Rings of Power. Maybe that's what it was.
How was it?
Again, the reviews are hilarious. I watch it for that. So.
Did you personally like it?
No. Well, I mean, yes and no. I mean, the visuals are pretty. Visuals are amazing, but the dialogue and the characters are generally annoying. So, all right. I will begin with a word of prayer. Dear Father, we thank you again for this day, for these students. I pray that you be with us, help us to use this time wisely to learn more math, and just help the students to ask good questions as they have them. Lord, in your name I pray. Amen. Any questions? So we have quiz Wednesday, right? So the quiz is on the things we covered the last 3 weeks and also the things that are in your homework that's due Saturday. So this week, in addition to the quiz, we're covering sections 2.3, 2.4, 2.5, and basically what this is on is functions and lines, right? So I want to tell you as much as I can about functions and lines today, so you have a shot at answering the questions on the quiz Wednesday, all right? I don't think the questions on functions and lines that are on the quiz Wednesday are going to be that difficult. If you understand what we say today, you got a pretty good shot at them, right? So let's get to it. So I ask you guys, what is a function? Do you guys remember? What is a function? Well, what's that?
It's like almost like a substitute or a key to a formula, I guess.
A key to a formula, a substitute. Well, yeah. How about you ever seen the machine interpretation? Like, it's like a box. It's like something that operates on things. So you could put an F on this box, and it has an input, right? It has an output. So you put X in, you get F of X out, right? Input, output. This is the way I like to think about it.
Is this worth writing? Like, should I write this down?
I mean, I don't know. That's like a deeply personal question. I don't know. Depends on like what you value. Is it worthy? I don't know. I mean, I think it's generally healthy to take notes, but some people take notes. Some people listen, process, and write a minimum. Some people write everything and don't think. To each his own. I don't tell you what to do in that regard. So this is, roughly speaking, a function. We take each input. Each input is assigned to a single output. All right. So there are 4, don't forget the top hat if you haven't already. There are 4 descriptions we can describe a function in 4 different ways, at least 4. 4 ways I'll talk about today for you guys, okay? So, number 1, we could talk about a formula. Number 2, we could talk about a graph. Number 3, we could talk about a diagram. And number 4, we could talk about a table of values. All right. The dominant formalism that we adopt in here is the formula. The formula viewpoint, by and large, is the way we think about functions. So let me dive straight into number 1. So, example, so we suppose we have f1 of x is equal to, oh, I don't know, 3 plus 2 over x. Excuse me, 3 plus 1 over x, rather. Let me keep it simple. F2 of x is equal to, how about x squared minus 2. F3 of x is equal to, let's say, 1 plus the square root of x. So I want to dig into the formula viewpoint here for a bit, all right? So these are formulas for 3 functions, f1, f2, and f3, all right? So let me give you a definition. The domain for a function is the set of allowable inputs. Right. And we write it as the domain of f of x is our notation for it, all right? As we call it.
What's that weird looking thing beside the
Definition?
Oh, all right. Thank you.
Good question. It's my stylized definition, I suppose. Now, what's the domain of f1 then? What's the domain of f2 of x? What's the domain of f3 of x? Can we figure those out? So it's the allowable inputs, right? So our convention for something like a formula is we say that the domain is all x for which the formula makes sense. So which x does the formula for f1 make sense? We need x except for x equal to what? What's the one trouble for Formula 1? 0. Yeah, 0 is a problem. So we just have to omit 0. So the domain of f1 we can write like this: minus infinity to 0, union with 0 to infinity, right? We just got to rule out 0. That's the domain for f1. How about the domain for f2? Two? No, I don't think 2. Minus infinity to positive infinity is the correct answer. The reason for that is just there is no trouble with this formula. We can put any x we like into it. In fact, any polynomial, right? Any linear combination of powers or any difference, sum or difference of numbers times power functions. This is, again, defined for any real number. So like polynomials, the domain is all real numbers. There is no trouble, right? No trouble for this function. How about, now I should be careful here. The domain for a function is the set of allowable inputs. And by allowable, I mean inputs which make f of x a real number. So that's what we mean by allowable. It has to be real valued, because our discussion here in this course is about real valued functions of a real variable. So sorry to be boring, but we need real outputs. If you want the output to be real, if you want to keep it real, for f3, what can't we allow? Negative numbers, right? Like minus 1 would be troubling, because if I plug in minus 1 this, I have 1 plus I, right? That would be complex. So did you guys say positive numbers? Is that right? I mean, it's mostly right. But to be clear, what can we allow here? Is the square root of 0 defined? I mean, the square root of 0 is defined, right? So to be fussy, this is the set of non-negative numbers. So like positive numbers together with 0 are the non-negative numbers. Yeah.
Why isn't 0 included in the first one?
Because it would get division by 0. Mm-hmm. So to figure out the domain of a function, we just have to look at the formula and decide what's allowed, what's not allowed, all right? What else do we think about for a function? Do you guys remember? Remember the range? What's the range of the formula? Set of output values, right? Right. In other words, it's equal to like what? F of x such that x is in the domain, right? It's the set of output values, right? Now, to figure out the range, that's a trickier question, okay? We can figure out the range if I share with you the graph. If we look at the graph of these three functions, right? So I defined the function with a formula. I'm now producing the graph, all right? Like so. Well, let me save myself room here. I'm going to do it over here a little bit. All right, so I'm going to look at the graph of these three formulas that I have. So I'm going to start with y equals 3 plus 1 over x. The way that's going to look, it's got a horizontal asymptote at 3, and this thing looks like something like this. All right, there you go. This is y equals to 3 plus 1 over x. Y equals x squared minus 2. That's got a y-intercept of minus 2. It opens up like so. Here you go. This is y equals x squared minus 2. Right. The graph of y is 1 plus square root of x. It starts at 1, and then it's like half of a parabola, opens like that. All right, now, let me just, so you don't panic, this is not, what I just did is not on the test. All right, like creating graphs is not part of test 1. With one exception, I might ask you to graph a line. So if I'm asking you to graph something by hand, it's probably going to be a line. That's what I expect you to be able to do. But creating graphs like this, this, and this, that's an after test 1 problem. So at the moment, I will give those to you and ask you questions about them. All right, so I created them for you. There they are. Now that we have them, we can answer the question, what's the range of each one of these functions? What's the range of f1? What's the range of f2? What's the range of f3? Right? So you guys can tell me, what's the range of f1 of x? What's the range of f2 of x? What's the range of f3 of x? Anybody want to get me started? What's the range of f1? Yeah. 3 to negative 3. No. It does have to do with 3. So the range is the set of y. Yep.
So it's like negative 3 and like
Then that funny looking math, that math thing. Yeah. 3 to infinity, right? That union. Your union is what you want. So like, you know. So yeah, the union of minus infinity to 3 and then 3 to infinity, which is just a fancy way of saying the range for f1 is everything except for 3. 3 is the one value, y value, that's not reached by the graph. That dotted line is the one y value that's not reached, which is at 3. What's the range of f2? So negative 2 included to positive infinity. Because the vertex in the parabola turns around at -2. So in particular, f of 0 equals to -2, which shows you that this point right here, right, this point right there is the point 0, -2, also known as the y-intercept of the graph, right? And so that's the smallest value it takes, and then it hits everything above that, right? So the range, all possible y values attained by the graph, -2 to infinity. How about example 3?
Bracket positive 2
So what?
bracket positive 2 to infinity, right? No.
I mean, you got the right idea, but look at the numbers. I heard 1, yeah, 1 to infinity. See the 1? It's got the, yeah.
I'm looking at the graph. I can't wait for
Be free. All right. So this was example 1. This was example 2. This was example 3. Yeah. I was trying to make them look different. So, give you some variety. Right? We good? All right. So that's the formula. Now, I should mention also, in terms of formulas, there's something else we'd like to ask you guys about, which is evaluating the formula, right? This is not, what does it mean to evaluate formula? So like suppose, example 4, let's suppose we had f of x equal to, 2x cubed minus x plus 1, right? There's a formula. Let's evaluate it. So evaluate f of 1 and f of Pac-Man plus a star. All right, there we go. F of 1, we can do, right? What's f of 1? What's that mean? Wherever x is, you put the 1 in. We have winner. So that is 2, right? 2. What is f of Pac-Man plus star? Same thing. You just take everywhere there's an x and you replace it with Pac-Man plus star. You cube that thing, you subtract parentheses Pac-Man plus star, and then you add 1. Same animal. I mean, here, I can make it less weird. What is f of, 2a plus 8 equal to? You take 2, you take 2a plus 8, you put it in the place of x, you cube that thing, and then you subtract parentheses 2a plus 8 plus 1, right? So this is function evaluation. Function evaluation just says that you look at the formula, and everywhere there's an x, you replace it with the thing you're evaluating the function at. You substitute x equal to that thing, whatever that thing is. You don't like, it's giving you, making you feel ill at ease, like this is a,
No.
it's
I do most of my math in my head.
ah,
I'm just good like that.
you got no, so like, you got no Pac-Man, like, in your imagination, like there's a star missing, like, what's the problem?
With numbers, I'm not good with
You're good with numbers,
symbols,
not good with symbols.
Pac-Man is.
So, does that mean everybody's just a number to you? Then that makes you, I don't know. I think people get in trouble when everybody's just a number to them. I don't know. Okay, I'm just messing around. But Where was I? Okay, so that's pretty much all I have to say about formula, right? If you have the formula, you look at the formula, you decide which x makes sense for it. That gives you the domain, right? To figure out the range, it's a pain. You got to draw a graph, right? If you have the graph, you can look at it and figure out the range, right? So we have domain, we have range. You can evaluate the formula. But see, this is where paper comes in, right? Because if you can't think about it in your head, you just put it on paper, right? That's actually good advice. No joke. I mean, it's like important to put these things on paper, not just try to do them in your head, right? Like it would be a fool's errand to try to figure out f of 1 just plugging the numbers in your head. Half of you probably could do it, but it's so much better to write it down so that if you make some stupid mistake, you can see it. Yep.
Can you figure out the range without drawing the graph?
The range, for example, for
those without drawing the graph.
the range, for example, 4 is everything, because every cubic goes from minus infinity to infinity eventually.
No, I meant there. Can you figure out the range without drawing the graph?
How can you figure out range without drawing a graph?
The domain in
Just
the
by
formula?
just by thinking about the formula? I mean, technically yes, but it's more challenging. Yeah. Okay, so moving on here, graph, the graphical viewpoint, right? So, graph. We good? All right, so let me give you a graph. So this time our starting point, how to define the function, it's not going to be in terms of a formula. This time the function is going to be given in terms of a graph. All right, so the graph looks like, I'll make it up right now. Maybe we go from, let's see here. I'll tell you this point will be minus 4, comma 3. Go like so over to here. That point will be 2, comma minus 1. And do open circle here up to like that. And this point will be, let's see here, 4, 7, 7, 4. All right, and then I'll be constant here like that until I get over to, let's say 10, 4. All right, so just to be clear, what I just gave you, that's given. All right, this is given. All right, this is our starting point now. So if you're given all this, right, this is y equals f of x. This is given. Then the question is, what questions can we ask about it? All right, what questions can I ask you about a graph given that? What do I mean by graph, by the way? Let me just take a second here and make you a definition. Definition, graph of a function, it's equal to x comma y, such that x is in the domain of the graph, domain of the function, and y is equal to f of x. In other words, the graph is the set of pairs x comma f of x, such that x is in the domain. So that's what a graph is. It's the set of points such that y equals f of x. Yeah. So that's that's how we think of graph. And I've given you a picture, right? The set of points which I've made red are the graph of a function, all right?
Why did it stop going up? Like it started.
It was given.
Oh, so this isn't from that equation.
No. No. You want an equation which does this?
That's what I was confused about.
I mean, if you want an equation which looks like this, I think I could do it, but it would take me some time.
We don't need to do it. I don't think we have time.
I think you should do it. You know, I think you should do it.
You are evil. you're like that. You know, like in the old cartoons, they got like the angel on the one shoulder and like the devil on the other. Yeah. You're like that, but for class. It's like it's a temptation, but no, that would help no one. It would amuse me for about 20 minutes.
Help me understand how
It would not.
Piece by piece, you know what I'm
It would definitely not help anyone.
saying? 100%. Go ahead.
Well, I appreciate that, but so let me ask some questions that you guys can answer. So f of minus 4 equals fill in the blank. Okay, f of 2 equals fill in the blank. F of 7. Let's fill in the blank for that one. And f of 10, fill in the blank for that. And hey, while we're at it, f of 9, fill in the blank for that. F is increasing on, fill in the blank for that. F is decreasing. Fill in the blank for that. F is constant. We'll fill in the blank for that. And what else? Oh, finally, last but not least, the domain of f of x equals 2. The range of f of x equals 2. All right. At least one of these questions is a trap, in the sense that that thing is not defined. Which one is that? Yeah, this, see, what does this open circle mean?
It's not equal to that point.
Right, minus 4 is not in the domain, so f of minus 4 does not exist. So that's the trap, does not exist. All right.
You got 2, 1.
F of 2, what's the value? Does not exist. And to be clear, we're saying it does not exist as like a real number. I mean, one might wonder, how is it that we're talking about it if it doesn't exist? So it does have an existence in that sense, but it doesn't exist as a number. Just saying. That was an example of an unhelpful comment. I blame you for me saying that. It's your influence on me to say that. I wouldn't have said that if not for you being here.
Everything you say is important. You know, so I'm just wondering.
Everything I say is important.
Taking heed of this.
That's a very high standard to put on my words. I don't know.
You're a math teacher, so everything you say is you're going to help us pass.
I'm going to help you pass. Oh, okay. Okay, all right. Fair enough, I do want you guys to pass.
Hey.
I mean, I'd love to see you next year, but I kind of don't want to either. I mean, I'm teaching college algebra next semester, but let's not recycle. Yeah.
Why did we say that f of negative 4 does not exist?
It's this circle right here. So this circle means that minus 4 is not actually in the domain. In contrast, over here, that dot's filled in. So like f of 2 is
So you would fill like
negative 1, right? So, and again, the idea here is that what's given in red defines the function. So I'm saying you can define the function by this picture. I don't even have a formula in this case.
Why did you put coordinates for that first circle right there? No, not that one. It's the third one. Go over to it. Go up one.
The other open.
Why didn't you put one there?
Oh, I don't know. Just, I forgot.
Okay.
2 comma 1. There you go.
So that means 2 would not be in the domain as well.
No, 2's in the domain because down here it's given f of 2 is minus 1.
Okay, so if there is one that does have it, and there's one that doesn't have it, that means it is.
Yeah.
Okay.
Yeah. How about f of 7? We got a 4. F of 10? 4. F of 9? 15. So you got to use your imagination here, but if this is actually a horizontal line, right, then this point here would be 9, 4. So it would again be 4. F is increasing. So what do we mean by increasing? We mean that as you go left to right, you're going up, right?
Not really.
Increasing from 2, right? 2 to 7. So we refer to the x values when we're talking about increasing or decreasing. Describing a function, we use x values by default. The only exception to that is when we talk about the range, we talk about the y values, all right? So where is it decreasing? It's decreasing from -4 to 2, yeah. again, we describe the function by the x values, all right? Where is it constant? It's constant from 7 to 10. There you go. And there you go. So, yep. Now, you could put brackets if you wanted to. You can put open bracket, open if you want to. I don't really care, but I should be careful not to include the -4 on that one. So, I mean, you could make your answer a little bit bigger. You could say like this, sure, you know. And yeah, I could do 7 to 10 like that if I wanted to. I don't want to fuss at you guys about that issue though, so I'm trying not to talk about it. I do appreciate the question though. Yep.
Okay, so the function will always be the y value?
The range is the y values.
Right. No, up there. I mean, or if, oh, sorry. What?
On your test, will we have to put brackets when it asks what is increasing and decreasing on?
I said I don't. I said either way is okay with brackets or open or closed. I do want either brackets or parentheses though. That much is true. So the domain, right, is the set of allowed x values. So for here, where do we go? We have x values starting at -4 but not including that, right? And there's an x value in the graph all the way over to 10. So the domain is -4 not included to 10 included, right? If you want to think about that, you could take a vertical line and just look at your picture. Every place the vertical line intersects the graph is a point in the domain, right? Yeah, this is kind of a precursor to the vertical line test. I'll talk about that in a minute. But so as long as there's at least one point, there better not be more than one. If there's one point in the graph which intersects the vertical line, then that's a point in the domain. The domain refers to x values, right?
There's 2 right there.
Here?
2, 1, and 2 minus 1.
That's not included. Open circle. So now, for the y values, if you think about horizontal lines, that's going to show you like where it goes to the y-axis, right? So I include -1 here, right? And I include values everywhere all the way up to +4. So the range is -1 to 4. Both of them included in this case. And that's that.
I should do another example like
Well, let's see, that was example 5.
an example stick to the same thing, but add a little flavor to it, you know what I'm saying?
Is this on just the test next week, or neither the quiz or the test?
It's quiz.
We got test
This is on the quiz?
This on the quiz, yep. Maybe not all of this, but some subset of it, yeah.
Time out, please.
Yeah.
We got a quiz this week,
We have a quiz Wednesday. That's right.
and a test next week.
That's right.
Test on what? Time out. Different.
The quiz is a pre-test, basically. What's that?
So if it doesn't cross the vertical line test, does that mean the answer's only fine for domain?
If it doesn't...
So is that...
Oh, okay, so, yeah, fair enough. Since you asked the question, let me show you another one. Since you guys asked. So if I had the picture like this, all right, so suppose this is -5, this is 6, right? And then I start over here again, like that, all right? From say 8 to 10. Okay, and suppose that's y equals f of x here. In this case, the domain would be -5, not included because of that open circle, all the way over to 6, included. I jump from 6 all the way over to 8, so I had a union with 8, and then 10, again, is not included. So yeah, that could happen. Now, there's a fair number of problems in your homework which are weirder than this, yeah?
No, but like if we had another one that's 6, right? 6 have another line under 6, but it is included. And then when you go through the vertical line test, there's going to be 2 6s.
Yeah. Oh yeah, that, if there was, like, okay, so just to go back to example 5, if I filled in that dot, then it's not a function.
So,
Because then f of 2 would be both 1 and minus 1, which you cannot have.
so what would we write on the line?
You'd say this is not a function.
What is
Yeah, you should do it on the
It's a relation. Okay, so example here, example 7. I'm going to come back to that vertical line discussion, so just hang with me here. So if you have that the graph of f is equal to, let's say, 1 comma 3, 2 comma 5, 3 comma 7, like that, all right? So there are, the other way we can describe a graph is if it just has a finite number of points in the domain, we can just list it as ordered pairs. So if this is the case, then you could write f of 1 is what? F of 2 is what? F of 3 is what? Three, 5, and 7, right? And this one, what's the domain? What's the range? What's the range? I heard 3 to 7. I heard 1 to 3. This is kind of correct, but we have to be clear what we're talking about. So the domain is 1, comma, 2, comma, 3. It's a set just containing 3 elements. You can't use the interval notation here. Intervals always have like infinitely many points in them if they've got more than one. So 1, comma, 2, comma, 3. The range is 3, comma, 5, comma, 7. The picture for this is exceedingly silly. If I draw the graph in like this, then I'll draw the graph in red. It's 3 dots. 1, 3, 2, 5, 3, 7. That's y equals f of x. There's not really a formula for this. It's just those 3 values. But there are problems like this in your homework, so I should talk to you about it a little bit, right? By and large, the dominant viewpoint we use in here is formulas, right? Like that. Now, so this is the other thing we mean by you can describe a function by its graph. A graph is a set of ordered pairs in this viewpoint. And the book takes the theoretical viewpoint that this is the function. It says the graph is the function. I'd like to make a distinction. I think of a function as a mapping, input and output, so I don't quite agree with the book, but whatever, it's a point of philosophy. But if you have an ordered list like this, you can decide whether or not it's, you can decide values of the function from that ordered list, all right? There's another way to express example 8. So also as a diagram. So here's a diagram for example 7, which is like this. If I do 1, 2, 3, I put my, 3, 5, 7. I mean, you don't have to put them in the same order or whatever, but the diagram is exceedingly silly here. It's like this. So that's another way to define the same function that we're describing in example 7 by this. What's that? So there, I mean, this diagram means f of 1 is 3, f of 2 is 5, f of 3 is 7, yeah? And then there's one other way you can describe it. You can describe it by a table. Table for example 7. Yeah? Which would look like this. Here's your x, here's your f of x. You got your 1, you got your 2, you got your 3 outputs, 3, 5, and 7. Right, so you could do like a table of values. So you guys were starting to ask me about, what is it? When is it not a function, right? And those are good questions. We should talk more about that. So I'll start with this. I'll do another one of these diagrams here. All right. So like, let's see here. Where are we? Example 8. Yeah. So here's one. Suppose we've got 1, 2, 3, 4, 5. And over here we got 6, 9, and Bob. There you go. So you could have 1 maps to 6, 2 maps to 6, 3 maps to 9, and 4 maps to 9 and to Bob, and 5 just maps to Bob. Right? So what this diagram would mean is f of 1 is 6, f of 2 is 6, that's fine, no problem there. F of 3 is 9. F of 4 is 9 and Bob. And then f of 5 is Bob. So is this a function? It is not a function because this right here, you got 2 outputs for 1 input. That's not a function. Right?
You would also include 2 points there, 2, 6, and
The 6 and 6? Oh, that's not a problem. So for example, 9, we could have like 1, 2, 3, 4, and then 5 over here. And then you could have a function like this. That would be fine. This would just be f of 1 equals f of 2 equals f of 3 equals f of 4 equals to 5.
Wouldn't it be constant, right?
Yes, this is a constant function.
But
Yeah.
on example 8, like what if you have like a plus or minus? That would yield 2 outputs.
If I had a what? A plus or minus?
Yeah. Or if like the function had like a square in it. You get like a
Plus or minus. Well, if you got plus or minus in your formula, that ain't a function. All right. For example.
not in the output.
Yeah, I'm talking about the output. You got plus or minus in the output. It's not a function, because if you have plus and minus both both going on, that's not a function. So, for example, if we have this graph, right, x squared plus y squared equals to 1, right? So here's the x-axis, here's the y-axis. This is a circle, right? And you draw a vertical line through this, right? Like so. Say the vertical line at a half. Where does the intersection of that line happen to the circle? These 2 points, right? So if I solve this, I've got 1/2 squared plus y squared equals to 1, which gives me y squared is equal to 3/4, which gives me y is plus or minus square root of 3 over 2. Which is to say, if this was equal to f of x, you'd have to have f of 1/2, right? It would have to be equal to plus or minus the square root of 3 over 2 if this was going to be the graph of a function. But we cannot have that. We cannot have f of 1/2 be both plus the square root of 3 over 2 and also minus the square root of 3 over 2. You have to pick one or the other, right? And that's tantamount to this graph. The one that's in black fails the vertical line test. What's the vertical line test? Vertical line test is that if you're given a graph in the plane, each vertical line crosses the graph at most 1 point. This vertical line crosses the graph which we're given in 2 points. Now be careful, I'm using the word graph in 2 different ways. We can talk about the graph of an equation. That can have all kinds of weirdo stuff. Graph of an equation can look like, here's another one. So like, what does the graph of an equation look like in general? The answer is just can be absolutely anything. you can find an equation that has a graph that looks like this. I mean, it's possible. All right? And so that's a graph. Is it the graph of a function? The answer is no. Because if I take this vertical line, for example, I got 1, 2, 3, 4, 5, 6, 7, 8, 9 different outputs for that one input. Right? If this is at 1, right? If that's at 1, then we'd have to have f of 1 is equal to 9 different things. This we cannot do for a function, right?
So what is it again?
Fails the vertical. This fails the vertical line test. What is it if it's not a function? It's just a graph. I mean, you can have any old equation. So, look, this right here, this is the graph. This graph right here is a circle. We have another name for it. But specifically, it's the collection of x comma y such that x squared plus y squared is equal to 1, right? This is a circle centered at the origin, radius 1. It's the unit circle, in fact. This is less familiar to your experience, but you can come up with crazy equations which give you all kinds of other wacky curves, you know? And you don't even have to use equations. You could do other things, like just say your graph is the unit square. You could just say, my graph is, I'm going to shade in. I could just say, I'm going to shade in this square right here. This is a subset of the, here's a subset of the R2, like this, yeah? That's a graph. It's a subset of R2. I can still say it's a graph. It's definitely not the graph of a function, because if I take a vertical line through this, I hit an infinite number of points. You know? All right. So how about, and we're done. But I started late, right? Dang it, I started on time.
Early today.
What's this world coming? I started early. I feel like you're just making that up.
How many questions is it?
Ha, ha.
He wouldn't tell you last time. Let me tell you this time.
Well, I was going to help you with your homework, but you've talked me out of it. All right, so, what? What? Yeah.
Any questions on the quiz?
So let me say it in words since I can't write it. The other thing, so we get vertical line test, right? But what if you're just given like a list like this? How would you decide whether a list like this could in fact be the graph of a function or not?
I mean, you could just graph it yourself.
Just graph it yourself? I think that would be, I mean, you could. How about this? What if I have 1, 3, 1, 2, 6, 7? Is this equal to the graph of f for some function? In other words, is this a function? The answer is no, because this would have f of 1 equals to 3 or 2. From, you see, though, so like basically, if you're given the function as a list, you have to make sure that you don't have repeated first entries. So there's a problem or two in your homework like that. I just wanted to give you a heads up. Yeah. But yeah, you could graph it and then apply the vertical line test, but not a function. No. The quiz Wednesday is the whole. You can get. It's fine. The quiz Wednesday is the whole class period. So on paper, there will be enough questions. Enough. I told you. There will be enough questions. I mean, I currently have 6 pages.
Are we going to be stressed for Tom, or is it going to be kind of like, no, we're good?
That depends